Good evening, ladies and gentlemen. Now, from Luke, Tony, and Rudy, you've heard a lot about the plethora of opportunities and technologies available with IMEC. And I'm going to talk about a technology that is the initiative and drives the IMEC India project. And so, before I walk further, I would like to ask the audience this question. Can you spot the predator in the scene? Because if you cannot, you're already dead. Anybody, by a raise of hand, can I get an answer? Has anybody able to spot? I guess not. And so, you missed out the Black Panther. Oh, now, why did this happen? Because the image that you saw first was about the intensity of light that was being reflected from the surface. Now, when I add color to it, you're able to see the differences and the similarities. In a way, I have tried to express the limitation of human vision. And in the subsequent slides, I will talk about a technology or a sensor that really augments our potential. And that is why, we always see the need of building up sensors, and in this case, an imaging system which takes us from the conventional imaging platform to a new paradigm. So, in the history, we see that there was photographic films invention and the SLR cameras, and so we were always trying to mimic human vision by camera inventions. So let's see how standard cameras work. So you consider the spectrum of 400 to 700 nanometers, and you compose an image from the blue region, the green, and the red, and you combine or compose them together up to get a color image. So the next challenge is, can we build a camera which looks beyond human potential? And the inspiration lies in nature. Snakes are known to have infrared vision. Birds are known to have five primaries, that means they can see many more colors. Honeybees can sense ultraviolet. And the most magnificent mantis shrimp can sense 12 primaries. It has a very complex eye structure. And so we were trying to mimic this animal vision, and we could see that in the 1960s onwards, we had the invention of hyperspectral and multispectral cameras. So now that we're talking about hyperspectral imaging, let me show you how it works in a very simple manner. So consider again the same wavelength range from 400 to 700 nanometers. And now we have the ability to take image at each individual spectrum of light. And if you closely see, you can see all these images are providing different intensities. So basically different information of the surface that is being imaged. Now, what you do with this, you compose together all these images and you generate a hyperspectral cube. And if I were to see the information that lies within this entire image data, this is the kind of spectrum I'll see at each particular pixel level. So this still doesn't make much sense. And what you do is, I'll give you an example of it. We have also a live demo to showcase this same feature. You take n different images and you try to bucket them based on their texture classification. And if you see the different spectras in the image, these are from the pixel intensity or the pixel spectral data from all these different image samples of leaves that you can see. So we reach another major milestone, that it is in 2000 we had the birth of cameras being integrated into cell phones. And so we had the age of miniaturization basically. So the next logical challenge was, can we miniaturize hyperspectral camera? And well, in 2010, IMEC builds the hyperspectral sensor. What it does is basically builds a spectral filter layer on top of a traditional CMOS sensor. So where is the current state of the art, if I was to ask? And you have an array of complex optical components which would require complex assembly, with bulky, they were expensive and not mass producible. Now IMEC has shrunk in the entire principle of such an imaging right at the sensor level. And so you can build this IMEC design spectral filters right on top of a traditional CMOS sensor. So I'll give you quickly some key features about this particular sensor. It's low cost, it has a compact form factor, it is high speed, and best part, it is scalable with imager maturity. And so we move even further. In 2013, IMEC prototypes a snapshot sensor. So the first one basically was an answer as to how will you take a hyperspectral image of a still object. But then we also wanted to have a movie or the functionality of a movie, and so we have the snapshot sensor, wherein you can generate a hyperspectral video data. Again, we move ahead with the core focus that we initiated with the standard hyperspectral camera, and again it has the same form factor, again the high speed, and again it is scalable with imager maturity. So where are the applications? And this is a key initiative from IMEC India as to where do we find the value in applications for this particular technology. Whether it is breast cancer detection, histopathology, eye disorder detection, or assisting real-time detection of malignant regions, I think hyperspectral imaging can be a real differentiator. Not just that, other industrial applications include quality management in industrial production. So basically we are talking about defect detection and foreign particle investigation. We can also look at counterfeits, forensic investigation, and now with the hyperspectral video sensor, we can even look at surveillance technology. So very quickly, I would like to reach my closing comments. So what does the future hold for hyperspectral imaging? Now, hyperspectral imaging is basically a marriage between the semiconductor technology, design aspects, computation, and optics. And you modify or improve any of these single components, all of them, or even any combination of them, and you start building the next generation of hyperspectral sensors. And now you would appreciate the fact that in 1960s, whereas we had hyperspectral imagers being built in space satellites and in aeroplanes, we have scaled the imaging technology right to the size of a thumbnail. We have for the first time brought out this technology from the area of laboratory research to industrial applications. There is no reason to doubt that tomorrow it could go out to consumer levels as well. And probably then we'll be able to build communities that will self-propel this technology even further. And at IMEC India, we are working towards that vision. And the last comment that I'd like to leave with all of you is, we will have the next million people use 1 billion cameras to create 1 trillion more images. Some of these cameras will be hyperspectral cameras, and some of these images will be hyperspectral images. Thank you very much.